So for this project, we needed to lift a can from a box and place it on top of another box. We can view this like a similar analogy to moving objects from one table to another table or perhaps into another box. There are several points that we have declared for this project. Here's the complete example. Here, the blue box, the dark blue, is our box 1, and the cyan box is our box 2. Here we have different points established. As you can see in the corner right here, there is a reference frame that has been marked with respect to the box. So if at any point we move the box around or something in the real world, we just need to find that position and the reference frames will be set accordingly to that. This is a workspace that we have defined. The same goes for the cyan box. It has one in this corner. That's its workspace, and these are the frames that have been defined according to that workspace. So the robot is going to go to make an approach to this point, which is like a point above our pick zone, and then it's going to approach slowly to our pick point. It's going to pick up the can, retract to the pick above, and then to home, and then it will go to the above position of the drop zone. Then it will go to the drop point and it will drop the can. Here we can see the point that I have been talking about, and downstairs, down here, we can see the movements. It goes to the home point, to the above the pick zone, to the pick point. It closes the gripper to grab the can, and then it moves. It returns to the above the pick zone, and it goes to home again, and it begins the procedure to drop the can. It goes to the point above the drop zone, then to the drop point. It opens the gripper and it returns to the point above the drop zone, and it goes to home again. We can see there are different things here. We can see the speed at which the movements will be done. It's different for each type of movement. Depending of where you're approaching, the speed needs to change, but also the movement. For example, here, from going anywhere, wherever the robot stands, to moving to the point home, we use the move J command to avoid those specific points where the robot rotates or twists in a very odd manner. Then if we need to make linear movements that are precise, we use the move L, that it will move the joints in a linear way. It also stands here that the speed will be lower and it will be a fine movement, meaning that it will approach to the movement and it will touch the point that we specified. Here it's a command where it sets this output or digital output to 1 to indicate the gripper that normally in the real life will be controlled pneumatically, and then we wait for a response from the gripper that the operation has been done, that the gripper is indeed closed. Then we retract to the point above, so we retreat from the table slowly, and well, then we proceed to do all the other movements. We come back to home, then to the above drop zone, and then we also approach the drop zone in a slow and fine way. We open the gripper with the same digital output, and we wait until it's open. It has opened the gripper. Then it will return to home. As an extra part for this video or this homework, the teacher told us to make an extra procedure in which we do something else with the can. In my case, I decided that we were going to do a scanning procedure, in which the robot would take the piece and move it to a photographing zone where there would be a detection procedure in which a camera would define if the object is in a good or bad condition. We can see that right here. This section from here is our photograph station. The black part is a backlight. Here is a plate where that diffuses the light to make it better, and this is the camera. So what will happen is that the robot will come here to it will drop the can here and then grab it again and it will go to analyze the can. Then it will take the photos and it will return the can to the box 2. We will see a little animation about the flashing of the box down here, but we can see the code right now, and I'll show you the demonstration later. Here it will go to right now it's at home, and then it will come back to the above drop zone. It will go down to the drop zone and pick the can yet again. Then it will retract and it will come to this P transition, P enter photo, and P photo. P transition is a point above this one here, above the box, in which we align the can in the orientation we want, and then we proceed to enter the space where it will, the photo will be taken. This one also has a workspace, this frame of reference, and these points are with respect to that frame of reference. This is a precocious point, so it will slow down and it will enter slowly to that part, to the photographing station. And here it will send a signal to take the photo. It will wait to the photo until the photo is taken, and it will send the signal output of 0 of taking the photo. Then it will go out from the photo booth to the transition, and then we'll go to the box 2 and open the gripper and drop the gripper, drop the can, and then return to home. So we are going to see right now a simulation about that. So we can see that it comes, it grabs the can, it goes there, and we can see the difference between speeds in the movements. Here, for example, we see that transition in order to align the can, and then it takes the photo, we see a flash, and it returns the can to the original position here, and it returns to home. And that's basically it.